a good place to look at sort of the other option. So before we get into this, our other option is what we call a roller camshaft. And the roller camshaft will normally be the cast steel, so a different material. On the roller camshaft, each one of those lobes is going to be perfectly straight across. So I got rid of that slight angle that was in the lobes. Instead of that lifter being almost flat or a little bit curved on the bottom, we actually stuck a roller wheel on the bottom of the lifter. And obviously this is a much bigger lifter, but this is what we call a roller lifter. So it has this roller wheel on the bottom. So as the cam rotates, the lifter will move across the lobe, and the lobe will push that lifter up to force the valve open and allow it to drop back down to allow the valve to close. By having this roller wheel and these nice flat surfaces, what's that going to do to friction? Decrease it. So we have very, very little friction. The flat tappet design, friction and wear was a big issue. With the roller design, friction and wear is almost minimal. So in the video, they mentioned that with almost any rebuild, you'd replace the cam and the lifters, right? And I kept telling you guys that doesn't really apply to newer engines. This is the reason why. If you had a flat tappet cam, you will replace it. You will replace all the lifters because they wear. If you have the roller camshaft design, generally this stuff will last a really, really long time. So we don't have that issue of flattening lobes nearly as much anymore. Any questions on that at all? So like I said, we'll see some other pictures of that in a minute, but it's a good place to kind of mention it now. So a couple other terms related to our lobes. On this, we're seeing sort of the base portion of our cam as well as the lobe itself. A couple different terms for you here. This portion of the lobe is what we call the base circle of the lobe. So anytime we're on the base circle of the lobe, and that's what's in contact with our lifter or other components, what would be the status of that valve? Closed. So when we're on the base circle, valve is closed. As we come up the sides here, that's what we call the ramps of the lobe. So while we're on one of the ramps, the valve is either in the process of opening or in the process of closing back down, depending on which way we're going, right? At the very top, that's what we call the nose of the lobe. So when we're on the nose of the lobe, what's the status of the valve? Fully open, right? So what we're measuring right now is what we call the lobe lift. So that's how far this cam is pushing that valve open. So realistically, this line here is invisible. We don't see that on the cam. So we really can't measure the lobe lift that way. So the way we would get that measurement is we measure from the nose of the lobe to the bottom of the base circle. So we'll measure that entire height. And then we'll measure this direction and we'll subtract it. And that will give us that lobe lift. So the higher the lobe lift, the further we're pushing our valve open, ideally the more air and fuel or the more exhaust gases we can move past it, right? The more power we can make. So for a performance cam, typically we're going to see larger lift numbers. So the concern with that though is if we're pushing the valve further open, do we have to worry about interference between the valve and the piston? Yes. Yeah. So as we watch some more of that video, you'll see how they measure for that. So here you see those other terms I mentioned. So here's the heel of the cam, basically the bottom part of the base circle when the valve's fully closed. Here's the nose when the valve's fully open. We have our opening and closing ramps. And then the very first part of the ramp here is what they call the lash ramp. So what do we say lash is another word for? Clearance. So valve lash is valve clearance. That lash ramp, that initial part of the lobe, is designed to take up that clearance slowly. So we slowly take up the clearance on the opening side, and then we'll slowly create that clearance again on the closing side. Remember, we don't want to take up that clearance really, really quick and hammer on that valve train because that's going to be hard on components. So another difference between flat tappet camshaft and a roller camshaft. If this lifter is pretty much perfectly flat on the bottom, that really sort of limits the design of our camshaft lobe. So that camshaft lobe has to be sort of nice and gradual and smooth in order for the lifter to operate nice and smooth. If we have a roller wheel, because we reduce that friction quite a bit, that lobe can be much more aggressive. So what that means is we can have a lobe where we basically get that valve from closed to fully open very, very quickly. We tend to keep it fully open for a little while, and then we close it very, very quickly. And ultimately, that's going to give us better airflow as well. So in that case, what we're changing is the duration of the valve. So lift is how far we're opening it, duration is how long are we keeping it open for. And so that's another specification you'll see for camshafts. And when we're looking at duration numbers, if you look at just pure duration, you can't always compare them very evenly, because if we leave the valve open for a really long time, but most of the time it's spending its time trying to get open or trying to get closed, and it's only really fully open for a very small period of time, we're going to have limited flow versus a can that can get it open quickly, leave it open, and then close it quickly. So one of the things you'll see if you're looking at performance cams is a lot of times they measure duration at 50 thousandths lift. So that's a very common measurement they use for performance cams. Now 50 thousandths, is that really a whole lot? Not very big? Not really, right? That's like the gap on your spark plug. It's not very much. But basically the reason why they go off that is if that valve's not even open 50 thousandths, is there really much flow past it? No. So once it gets to 50 thousandths, that's when we really start to have some flow past that valve. So that's just a more comparable number versus the true duration. So this is kind of the usable part of the